excuse us for the delay, and I'm very, very happy to introduce Professor Ben Shneiderman. He's an emeritus distinguished university professor in the Department of Computer Science and a founding director of the Human-Computer Interaction Lab and a member of the Institute of Advanced Computer Studies at the University of Maryland. So there's a very long CV, but I would actually say that he's one of the founding fathers of this entire field of research. And in the talk today, I think that he reveals a new area which suggests a new synthesis in which artificial intelligence algorithms should be combined with human-centered thinking. And it's something that has been in the long thinking, in the long run, like the last years, in the thinking of many people. How do we integrate the human in the loop, or how do we make the human the center of this area? And I think there is a whole new approach here that takes an overall look, and I'm looking forward. And thank you, Ben.
Thank you, Ossie. I appreciate your making this happen and the team with you. And sorry to all for the delay in getting started, but we're here, and I will extend the session a little, and we'll be okay. So let me share my screen. Are we ready? And okay, good. Good morning. So as Ossie said, this is a new and interesting direction for all of us, and it's one I feel very passionately about, and I'm very happy to have this opportunity to talk about it with all of you and look forward to questions and discussion. So I'm always happy to wave the flag of the Human-Computer Interaction Lab at the University of Maryland that began 38 years ago, a collaboration between computer science and College of Information Studies with partners across campus, including the Maryland Institute for Technology and the Humanities, MITH. And you can see our work on the HCIL website and a video describing that. So I'll be referring to the work of this group. I hope some of you know me from my book, Designing the User Interface, now in 6th edition, and requiring a team of 5 people to put together this remarkable story about how this relatively small community of researchers had a dramatic impact on changing the world and making it possible that 2 billion people have a mobile device in their pockets, or more than that, and can use it to be in touch with family and friends and physicians and get their education and so on. The book covers important issues of direct manipulation in theory and design strategies for menus, speech and search, social media, information visualization, and lots more. We'll be coming back to talk about some of the lessons from this book. Some of you may know me from my work. I'm always happy to tell these stories of how a small idea had a huge impact. In 1984, our group developed the idea of highlighted embedded menus that would be highlighted in the screen. We tried different colors. Red was bright, people got it, but they tended to read the text less and therefore remember less of what they read. The light blue, which Tim Berners-Lee adopted for his Spring '89 manifesto for the web, became the appropriate way to move forward with that. We also developed the tiny touchscreen keyboards that are so prevalent on mobile devices. In those days, the 9-inch wide keyboards on touchscreens were the standard, and we made a 7-inch and then a 5-inch and a 3-inch keyboard, and we showed that actually people could type on a 3-inch keyboard because we implemented the strategy called lift off. Most touchscreens worked when you landed on the position, and so sometimes there were errors. But if you could put your finger on the screen, get a cursor, and slide it back and forth till you got the character you wanted, and then lift off, you could get your job done. Photo tagging was also our work, and I hold a patent for tagging photos by dragging the names and having them stick on the screen. But most of my work has been about information visualization, which will have an important force in this discussion today. So our early work in the mid-90s on Spotfire developed and refined the notions of multiple window coordinations, of double box sliders by which you could move the sliders and then all the windows would update simultaneously. There was also brushing and linking, so selections on one screen would highlight items on the other window. Spotfire became a commercial product in 1997, grew to 200 people, and was acquired by TIBCO in 2007. It remains one of the leading tools, not as widely used as a wonderful system called Tableau from our colleagues at Stanford, but Spotfire remains a respected, strong tool used by millions of people. And the tree maps here showing a visualization of the stock market the day after the election in the US. The large areas indicate the market capitalization of the big companies like Microsoft, Apple, Google, Facebook, Amazon, and others. The color indicates green means it's been rising and red means it's been falling. So that's another beneficial tool that's been widely used and implemented since 2014 in Excel, making it available to many for many different applications. Our work on network visualization on the lower left with Node XL produced a widely used tool that's the most widely used for educational purposes. And our second edition of the book in 2019 made that even more widely available to many people. On the lower right is the medical visualization tool called EventFlow, but it became used for many different events, sequences. In this case, this is the admissions of the pediatric emergency room at Children's Hospital in Washington, D.C. And the proper sequence of actions are these four colors, the red, orange, green, and blue, followed by this big gray area, but only half the patients got that. Otherwise, there were 29 different errors that these physicians made, and so the training was changed and hospital procedures were improved. So that's been most of what my time is, and the takeaway lessons from that is the goal of visualization is insight, not pictures. And visualization will play a role in our discussions throughout the day. Now, while doing this work, I wrote down in a playful way the idea of design, which has become known as the information visualization mantra. Overview first, zoom and filter, then details on demand. This phrase, embedded in a paper in a second-degree conference, Visual Languages and Computing, now has more than 6,000 citations, which is a remarkable number. And I think the reason people gravitate to it is because it asserts the centrality of human control. The overview, whether you have 1 million or 1 billion items, the overview first is meant for people to see, for humans. It's a human-centered approach. And then the user can zoom in on what they want, filter out what they don't want, and then click for details on demand. It's not a perfect mantra, but it works for many, many applications. And so that became an important idea, and we'll return to this later in the talk. So I take a little pause here, and when you see this image, it's a time for pause and reflection, and later on, it'll be a time for questions as well. And Ossi Mokrin will handle the questions, and I'll try to respond as we can, as much as we have time. But this kind of meditative scene should let you reflect and think about the move to the new directions. Where are we going? And that's what today's talk is all about. The rise of AI as a topic is no secret. It's widespread. Companies, governments are all racing to highlight AI and put it to work in many applications. The Rise of the Robots by Martin Ford predicted a world of unemployment and robots everywhere, replacing people. Nick Bostrom's superintelligence advertised the idea of artificial general intelligence, AGI, and the inevitability of it. And the only question is, how soon would it take? How soon would it arrive? And The Final Invention is James Barrett's book about the idea that once we invent an artificial intelligence as smart as humans are, then it will take off and continue to reinvent new forms of AI. These present a scenario which has many hopeful aspects, but also many fearful aspects as well. And I hope today to, as I have done, reset my thinking, and I hope to help you reset your thinking to believe there is another way forward. There is another view of the future, a view which is centered on people, which empowers people, which augments them, amplifies their abilities, and enables them to do creative work. That's what we're going to be looking for. Now, many people have raised concerns about AI. Maybe the best one, if you read one book, read Cathy O'Neill's Weapons of Math Destruction, which talks about how big data increases inequality and threatens democracy. Her potent examples, written in a wonderful way, remind us about the dangers of AI and machine learning, and it's had a huge and positive impact on influencing the development of AI to bring attention to fairness and bias and making unbiased systems. So we'll be coming to that. And I just mentioned one more of the many dozens and dozens of books about AI, the recent one by Gary Marcus and Ernest Davis on rebooting AI. And they write in the first half of the book a very critical review of the current state of AI. So much of what we read about AI strikes us as pure fantasy, predicated on a confidence in AI's imagined strengths that bears no relation to current technological capabilities. So that's a very critical way. His view of the future, or their view of the future, is that the solution is more AI, common sense reasoning, maybe conscious machines, sentient beings, and other notions that reinvest in the technology. And I'm here to try to change your mind and talk about human-centered AI, AI that enables people to do their work, to collaborate with people, and to use the technology to empower their efforts. So that's going to be the tag phrase: amplify, augment, empower, and enhance people. That's what we want to do. Amplify, augment, empower, and enhance people. Nice idea, but the question is, how do we do this? Well, the guiding philosophies will be here. This will lay out the outline of what I've been thinking about, and the highest point is to stress human values, the rights of people, the justice, racial justice, access to justice forms, and the dignity of all humans. People are different from machines. People are not machines. Machines are not people. We're going to do this by remembering that the goal is to support individuals and support their self-efficacy, their creativity, their responsibility, and their social connections. People are inherently social beings, and we want to connect them with people. Okay? And we're going to do this by designing tools that are reliable, safe, and trustworthy. And in the second part of the talk, we'll focus on the team strategies, the organizational strategies, the industry, and the government approaches. Now, this is all done not because we want the technology, but because we want to help people. And the stakeholders, there are many, many more, but these are 5 of the categories of stakeholders whose approach I hope to influence the researchers who develop new ideas, the developers who implement them, the business leaders who manage that, the policy makers who regulate and intervene, and the many, 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 many users who will potentially benefit from these developments. However, there are equally threats, and we have to remember every time we develop new technologies that there are real dangers. There are unanticipated ones, and there are ones that we can anticipate. And one of our challenges is to be more and more effective in anticipating the threats. The threats come from malicious actors, whether they're terrorists or hate speech promoters or political oppressors. We have many different categories. Criminals. I think the largest use of AI will be by criminals who will use it for cyber attacks and other scams and so on. I think there's a threat of bias in the data, and a big part of the effort in AI and elsewhere is making unbiased and fair systems. We'll be coming back to talk about that. And the flawed software that produces unexpected events. And so we'll be talking about how to reduce the flaws. You can never eliminate these threats, but you can do your best to reduce them. This talk has 3 parts, and this is also the outline for my book. The first part will be the HCAI framework to shift our attention to a new way of thinking. The second will be the design metaphors we use and the language and even the visual representations. That will constitute the rest of part 1 of this talk. And then the second part will be the governance structures and 15 recommendations. And this is more or less the outline of the book that I've completed and is now in production with Oxford University Press for publication in early 2022. So this is an early view of that idea. And the website there gives you access to that information. The links to the slide decks for this talk are available on the IUI website. Okay, well, I should start again from the high-level goals, and would be helpful to mention the UN Sustainable Development Goals. Every technology project should at least be reflecting and guiding on how their work helps to support the 17 Sustainable Development Goals taken by the United Nations in 2015, with the goal of achieving improvements by the year 2030. There are 169 metrics that are used to measure improvement. Some of these have already made good progress, and others still need more attention. But goals like no poverty, zero hunger, good health and well-being, quality education, gender equality, clean water and sanitation, and so on are the things that will guide us. So we should keep this in mind. It's a way of choosing projects. It's a way of thinking about how our work can have as much impact as possible. Another sort of underlying philosophy is to say, as I have already said, people are not computers and computers are not people. And my phrasing here is to make a bumper sticker that says humans in the group, computers in the loop. By that I mean humans are social connections, social people, and they want to work in groups, and they have supervisors, they have peers, and they have staff who work for them. And that's a common pattern in many organizations. And so we have to think at every moment about how human behavior is shaped by its participation in a group. And we do want those computers, and we want the computers to be in the loop. Now, some of you may recognize that this is a flip on the general idea that we keep humans in the loop, which sounds to me like sort of a limited idea, and I wanted to make sure that humans are the ones we focus on and that computers are what we have in the loop. And that's what we'll see in this presentation. What are we after? I've already mentioned these. Reliable, safe, and trustworthy are the central goals, but there's a large number of other goals that have been put forward for systems. They should be explainable and interpretable. They should be fair and unbiased, agile, dependable, robust, resilient, available, and so on. Usable, observable, comprehensible, transparent, private, and secure, and so on. So there's at least 30 terms that have been discussed in the literature, and I've tried to organize them in a sensible way. And this list, a bit dense here, but gives you some way of thinking about the goals and the measures and the ways of assessing AI and HCAI systems. There are the virtues of the system itself. That is, can we measure the trustworthiness of a system? Can we know if a system is responsible or humane? Is it ethical? Does it support well-being and benevolence? Is it secure and private? These are attributes of the system itself. But really what most people think about are that it performs well in practice. And therefore, phrases such as robust and agile, reliable, dependable, available, resilient, adaptive, and testable, verifiable, validatable, certifiable have all been used, as well as safe. But there's more. There's the clarity to the stakeholders. So it should be accurate, fair, unbiased, accountable, liable, transparent, a big word. And we'll be coming back to that as well. And should be interpretable, explainable, and usable. And then there are other attributes of a system that enable independent oversight, that it should be auditable. We'll be coming back. That's a big point for me. Trackable, traceable, redressable. And if you've been harmed, other ways to request a review and gain compensation, and so on. And that it complies with accepted practices. So this is an extended list, and it's a short list of what might be the potential projects for PhD or master students or research groups. And it shows the richness of the field, its importance, and how we might approach its progress. All right, so that's my first pause and first room for questions. Any questions or challenges, comments so far?
Carol Smith joins your recommendation for weapons of mass destruction. And,
great, thank you. I don't see the chat button on my Zoom screen here.
It's on YouTube. There's a lot of people chatting on YouTube currently.
Okay, maybe you'll just handle that.
Tatiana is also monitoring the chat and will help us with the questions. But people join your view of rather a scary world if people will not be the ones we think about, but machines.
Okay. Good. Anything else? Any comments?
So far, this is it. I don't see any.
Okay, that's fine. There'll be other chances for questions and comments in a moment. Where'd I go? I don't, oh, here we are. Sorry, nope. Lost my screen share. Do you see my screen now? Yeah. Do you?
We see the background. The
background. Okay. So we proceed to the first idea of, there are three fresh ideas in this talk and in the book. The idea of the
There are HCI. 2 questions.
What's that?
There are 2 questions if we are
okay.
Here. So Simon Nutfield is saying it is overly optimistic to ask for ethical AI when us humans can't agree on what counts as ethical.
Absolutely. I mean, there's no single definition of what is ethical, and what's ethical will be different for different people. And that's why human discussion is necessary. Yes, I think we have to accept those differences and find ways to make compromises. I've always found that ethics and ethical discussions are a useful starting point. They're an important foundation, a good background, but I would call them the weak cousin to design. And design is where the principles of ethics get put to work. And so this talk is more about design than it is about ethics. But I do think we have to start with some ethical foundations and respect the differences that there may be. Other question?
Yeah, actually a couple of more questions. Do you consider biases as threats, and are you going to discuss them?
Yes, I will discuss them. Yes, biases are one of the 3 threats, biases in the data, but also biases in the assumptions of the designers and the programmers and the managers.
Okay. And another question, and another question by Christopher Clark. A lot of these seem to apply to software systems in general. Do you think AI has moved some underlying issues of general development into the public domain?
I do think so, yes. Very good point that the concerns we raise here should be something that every system developer, designer, implementer, manager should consider. They've come to the forefront for AI, because AI has been so widely seen as a fundamental shift and new form of technology, and also maybe because AI's results are not always predictable. And therefore, we have a technology that's sometimes slightly out of control and sometimes with harmful results, as we'll see. So we can't prevent every problem, but we can do our best to minimize them. And when problems arise, to track them so that we can stop them from harming further people. We'll be coming back to that a lot. Thank you. I'm going to move on now. So the first section is about the HCI framework. And that notion emerges from Tom Sheridan's 1978 work with Bill Verplank, a graduate student at the time, which proposed 10 levels of automation or autonomy. And myself included, in my 1986 first edition of the book, Designing the User Interface, I had a section labeled Balancing Automation and Human Control. And I bought into the idea that you had to choose some point or along those 10 levels of autonomy or automation where you would design for. And if you increase the computer's automation, you necessarily reduced human control. This zero-sum game was widely accepted and is still accepted by many. And I became less and less happy with that as I went through the later editions of the book. And but that still has become a widely used notion. The levels of driving automation, the Society of Automotive Engineers put out this 6th level of driving automation, from no automation to full automation. Again, a linear model. But I came to believe that it was possible to ensure human control while increasing automation. And that's a bit of a puzzling statement. And if you reflect on it, you may wonder, as I did, how can you do that? How can you increase control and also increase automation? And the strategy leads to breaking into 2-dimensional model, where we have from low to high levels of human control and from low to high levels of computer automation. And maybe a more productive way to look at this is to see it as a 2-dimensional layout. So we can have human control on one axis and computer automation on the other. And our goal is to build reliable, safe, and trustworthy systems, which I would say would be more towards the upper right-hand side, with high human control and high automation. Let's take a look at some examples. What do we think of? We think of reliable, safe, and trustworthy systems like an elevator. There's lots of AI and scheduling the elevators, but when you walk up to the elevator area, you press the button, the light goes on, shows you that the elevator is currently at level 3, and it moves down from 2 to 1, and the doors open. And you enter the elevator, you choose 6th floor as your destination, the light goes on, there's informative feedback to let you know you've accomplished that, and the doors close, and then it shows you going from 1 to 2 to 3 to 4 to 5, 6. So it shows you your current status, your expectation of where you're going, and it moves you along in an orderly way that's become reliable, safe, and trustworthy. Similarly, your digital camera has a huge amount of AI and automation in it, from setting the aperture and the focus, reducing hand jitter, and many other features. At the same time, the user, you, can point the camera where you want to and get immediate feedback as to what the picture would look like and what the lighting would look like. And then you can zoom in on what you want. You can click and get the decisive moment to capture the image that you want. So that's the way I think a lot of technologies should be done, that give users the benefits of powerful automation where it's reliable and safe and trustworthy, and allow them to override it so they can override the focus or the lighting, and they can set many, many options on their cameras. And they are, since great, fully in control. This is their camera, their photo, their creative moment. And that's what we want to support. So there's a clever balance in digital cameras as a good model. Now, we also have cases, of course, where we do need high levels of computer control for pacemakers that are embedded and planted in chests to regulate the operation of the human heart, or the airbag in your automobile, which has to be deployed within 200 milliseconds to be effective. And so those are places where we would put a greater level of computer control. We also might think of a bicycle or a piano where we want human mastery. So the bicycle and the piano are high levels of human control. We do what we want, we explore, we try the bicycle, we fail, we play the piano, or we make creative movements on the piano. And then, of course, there are low control and low automation items, but those are, a different category. So this opens up the possibilities for design. And I'm going to take some more examples so you can see and you can begin to think about how you would redesign products that you're working on or systems that you're developing that would explore these 4 quadrants and everything in between. Before, I guess I should add, there's a danger also of excessive automation and excessive human control. There can be too much automation, as happens in many cases that lead to dangers, most notably the 737 MAX, where the system was so highly automated and the designers were so confident in their autonomy that they did not even inform the pilots of its presence. And invisible AI is unethical AI. So that the tragedy of those 2 crashes, which received so much attention, there are many, many stories about how that happened, but I think part of that story is the belief that a perfect automated system could be built and the removal of human control in that case. Similarly, there's dangers of excessive human control, and most mature systems have interlocks, guides, or limits on what people can do. So in a very simple case at home, in your self-cleaning oven, if the oven has been set to self-cleaning and the temperature is above 600 degrees Fahrenheit, you cannot open the door because that would be very dangerous. Okay, so those ideas are well established in human factors engineering and design of commercial tools and appliances, and those will become important lessons for us to remember. So this is the landscape of the framework, the 2-dimensional framework. And let's take another example, the morphine drip bag from the times of, let's say, World War II or the 1950s. A bag with morphine would drip into an intravenous line to a patient and deliver a steady flow of morphine. Now, unfortunately, this was a problem because it could deliver too much or too little morphine. And so the idea of an automatic dispenser that might even have a monitor on the patient's heart rate or breathing rate would regulate the amount of morphine that was given. But this approach, while it has benefits, does not respond to the patient's needs. And pain is not something that can be measured by machines. And so you need to give the user the chance to control it. And so the patient-guided dispenser became a way of increasing human mastery and control over the system, taking control away from the computer, and giving it to the human. There are limitations there from excessive operation, that patients can only get so many doses or boluses of morphine per hour. And so that ensures that they won't get an excessive dose. Now, the next stage for that becomes patient-guided, but clinician monitored. And the potential that there is a centralized hospital facility that monitors dozens or hundreds of such devices to see how they're all doing, how they're operating, to learn what different patients are doing, to detect problems, failures of the devices, or dangers for the patients. So that kind of centralized monitoring is becoming more common in hospitals, where there's a control center that may supervise these many devices and many other aspects of hospital operation. I think the idea of centralized control centers are an important one that we'll see rising up in many areas, including self-driving cars. So we'll come back to that theme. All right, another example here is early cars, 1940 cars. I would say progressed to a 1980 car, which gave a lot of human control, but the 2020 car, which has increasing levels of automation, adds more more computer control. And I think the 2040 car, I hope, will have attributes of reliable, safe, and trustworthy that will bring the benefits of low accident rates and higher performance. I think we still don't know the situation about the safety of self-driving cars. I might ask you to reflect for a moment, how many deaths do you think there have been from Tesla cars? And, we think of 2 or 3 or 4 or 5 that we've heard about in the news. But if you go to the website called Tesla Deaths, you'll see the last time I looked, there were 169 deaths in Tesla cars, which is a lot more than I expected. Now, you may say, well, how many of them were done while the full automatic driving, full self-driving system was engaged, or the autopilot system, as Tesla calls it? And we don't know is the answer. Tesla may know, but it's not letting us know. And so the idea of reporting and knowing when failures have occurred becomes very important. The National Highway Transportation Safety Agency administration does keep data about other things, and there's 122 reports about surprising, unexpected accelerations of Tesla cars. So there are some mysteries about what's going on. I don't think we have reliable, safe, and trustworthy self-driving cars. The question is, insurance companies, which I'll come to later in the second part, have a role to play here. And the question you might ponder is, should insurance companies request higher premiums or lower premiums for those who have self-driving cars? I don't know, and the insurance companies don't know either, because they don't have the data. So that's going to be a very important force of transparency and openness in reporting the data from different failures. We do have the National Transportation Safety Board, the NTSB, report on a few of these crashes. The early one in 2016 generated a very readable 60-page report that's available on the NTSB website that you can take a look at. And it does cite potentially excessive automation as a danger there. It also requests something near and dear to my heart, which we'll talk about in the second hour, which is audit trails have more detailed information than they currently do, like the flight data recorders on aircraft. And one final example here of a two-dimensional design for wheelchairs. The old-fashioned heavy wooden push chairs required a caretaker, low automation and low control for users. Then we got to the hand-powered, user-guided wheelchairs that healthier users of wheelchairs could wheel themselves around, and that led to other creative efforts such as Paralympics and basketball and soccer for people in wheelchairs. So hand-powered and user-guided became a strong form, and then more recently, robotic forms of wheelchairs which would automatically drive you to frequent destinations across many blocks in your neighborhood, brought many advantages. But I think the further direction is motorized, joystick controlled, teleoperated, and programmable chairs. And those are increasingly becoming part of the landscape for wheelchair design. So I hope this two-dimensional model opens your mind to the possibilities that we can have high degrees of human control and high degrees of automation. And the way we'll accomplish that is by automating the things which we can, where there's reliable performance, and keeping user control for the things where users want to be in control. Okay, so there are a few extensions to this two-dimensional model. Some have suggested I need a 3 or a 4-dimensional model, and some of those suggestions are here. There are different application categories like lightweight recommenders for films and for restaurants or books. And in those cases, failures are maybe even fun. They're surprising, they're interesting, and we shouldn't worry so much about failures. There are more consequential recommendations in medical care, legal, and business situations. And then there are the serious life critical applications. And so one of the ways of making a finer distinction to this HCI AI framework is to think about the consequences of failures. Another way is to think about the different situations of use. Rapid performance, like airbags, give you another set of concerns and maybe require a higher degree of automation. Long duration, like pacemakers, means maybe also need a automated system. On the other hand, pacemakers increasingly are becoming supervised devices that are monitored externally on your cell phone or the manufacturer's control center, which may collect data from thousands or tens of thousands of implanted pacemakers to improve performance for everyone's device. Also, remote locations. Oops, a little typo there. Remote locations, like on the surface of Mars, require a reconsideration. But as we'll see, the Mars rovers are also a happy blend of machine automation and human control. Finally, restating this notion of the fine structure or microstructure of design that I think you have to consider. You should automate where reliable performance is possible, but allow overrides. So that's kind of one strategy. The other is to give human controls where desired for creative flexibility, where automation is uncertain, but at the same time, you need to prevent human errors. And finally, I encourage to think about supervisory control, control centers, which can take over operation of devices. This commonly seen in ringer systems in your home, where you can open the door remotely. You can monitor babies remotely, and many other devices, including increasingly teleoperation of automobiles. It's a feature being built by most of the automobile manufacturers, although rather quietly, because it negates the central dream of the self-driving car, a misleading dream, I might say, and allowing teleoperation when requested or when necessary is increasingly seen as a way to improve safety. It also gives this central control center the chance to collect aggregate data from the performance of tens of thousands of cars and thereby improve performance for everyone. Okay, another chance for a pause, another chance for questions. Aussie?
Hi, Ben. Ben, we have a couple of questions here. So the first question comes from Aurora, and she asks, are you considering AI and accessibility?
Oh, yes, absolutely. I hope the wheelchair example shows that, but I think we want to make sure that the accessibility features of a system are supported by AI, not compromised by it. It's a very strong concern. University of Maryland is a world leader in this topic. The Trace Center, run by Greg Vanderheiden for almost 50 years, is a world leading center for developing accessible technologies, and the technologies on your Mac or your PC laptop were strongly influenced by the work of this group. So yes, I continue to see AI, and there are benefits, and even in the closed captions you see on the bottom of your screen are one of the benefits in accessibility.
Yeah,
thank you.
Thanks, Ben. Yeah. So the next question comes from Jason, and he asks, when you mention AI could help human goals, what methods do we use to research those human goals? Do we use the same HCI methods like GOMS or task analysis or something else?
Yes, the human goals we set, such as the UN Sustainable Development Goals, are one challenge of things. But in every project, we need to collect user requirements initially. GOMS is good for very specific cases, repetitive motion, repetitive small actions, but observations, interviews, surveys, and the usual ethnographic approaches to determining user needs, and of course, where possible, stakeholder involvement in the design process in the method that's often called participatory design become really important. Keeping them involved along the way is a further challenge. Yes, thank you.
Yeah. So the next question comes from Sharon, and the question is perhaps a bit out of the subject. Will robots/AI ever be able to create common ground with humans to create a connection?
To create what?
Will social robots/AI ever be able to create common ground with humans to create connection?
We'll come back to that, but no, I think social robots are not the best way to design technologies. I think it's one of those misguided directions that I'll come and address in the second part of this talk directly. Just to say briefly, there's lots and lots of history for 200 years of people seeking to produce social robots, and they're wonderful. They're entertainment. They're good examples. They inspire people to think about fresh ideas, but none of them have really gained commercial success, and I don't think they will. Medical mannequins and crash test dummies are probably the best examples of success stories, but we'll talk about other things that are spin-offs from that, such as Alexa, Siri, and other voice user interfaces, and potentially some of the pet robots, which have proven to be valuable for patients with dementia. But no, I don't think that social robots will become widely used, and I'll talk more about that in the second part.
Yeah.
Thank you. One more question?
Yeah, there's another question by Ruxan. I agree with you, but people may argue that the reason for using automation is to reduce the operation costs and workload. Automation can be safe enough. How would you address the debate?
Yes, I mean, I think when it's going to be safe enough, reliable enough, and benefit people, I'm all in favor of automation. I understand and certainly concerned about the issues of widespread unemployment. I don't think widespread unemployment will happen. I think the history is very clear about that, from 200 years ago in the Luddite rebellions in Scotland against weaving machines, down to Amazon's story. And in 2012, Amazon bought Kiva Robotics, and the belief was that Amazon's workforce of 125,000 people would shrink because the robots would take over and do the jobs. Well, here we are 8-9 years later. Amazon has lots of Kiva Robotics, and it has 1.3 million employees, 1.3 million employees. Yes, there's controversy about whether those jobs are good jobs or bad jobs, and I'm very well aware of those issues. Amazon has some positive aspects, but many critical aspects about the workforce, and we could discuss that at length. But the issue about employment is that employment growth has surged, and it's happened because Amazon provided a service that was relatively cheap and relatively effective. And so customers, especially during the COVID pandemic, came to Amazon for its products. So the use of Amazon exploded by a factor of 30, but the number of employees grew by a factor of 10 only. And so that's the benefits of automation. It does allow increased productivity, lower prices, higher quality products in most cases, not every case. A great concern is the inequality in society and economics, and we need to do more to deal with the inequality and the disruption caused by automation. These are serious concerns. There's a whole chapter in the book that discusses this. And I encourage you to read the recent report from the MIT Work in the Future report, which describes these issues and gives a reassuring sense that this widespread unemployment is not going to happen. Martin Ford's book in 2014 predicted it by the year 2020. That has not happened. COVID has disrupted employment, certainly, but we seem to be on a path to restoring employment. I don't think robots will have that profound and negative effect in the future. There'll be benefits to improved automation and flexible manufacturing systems. There'll be disruptions, but I think overall, I'm an optimist about the benefits of automation. Again, beware of the cautions and the dangers to workers' lives and their health. Thank you. I'm going to move on now. It's 6 minutes past the hour. I'll go a bit past the expected time of 15 minutes past the hour to make up for our delay. Okay, so this is our guide for the talk. We've covered the first notion of the HCI framework, and the notion there is shifting from a one-dimensional to a two-dimensional model, and realizing we can have high levels of human control and high levels of automation. The second part will be about the design metaphors and the way we envision future technologies. Second part of the talk here, but the second part of the presentation after the break will be all about governance structures and the 15 recommendations for that. All right, so the design metaphors that we're going to invoke are summarized in this table. And on the one side, we see the history of AI often defined by strong activity around these kind of words: intelligent agents, thinking machines, cognitive actors, AI, and so on. Teammates. The notion of teammate, collaborator, partner is widely used. And I'm a dissenter about that notion. I don't think computers can be our teammates, collaborators, or partners. They are not responsible, and they are just different. And designing machines as teammates, I will point out, is suboptimal. Assured autonomy is sort of the child of autonomy. Since autonomy hasn't worked out that well, the phrase has become assured autonomy of systems that will take care of themselves and be self-directed. I prefer the notions of supervised autonomy, where human control and oversight is given. And actually, I'd like to get rid of the word autonomy altogether and stick to the notions of super tools and active appliances. Social robots are widely heralded as the future: anthropomorphic, human-like, humanoid, androids, bionic, bio-inspired, are all the notions that are put forward. These will have some inspirational value, but I will stress the benefits of, on the right side here, super tools that extend human abilities, teleoperated devices, supervised autonomy, and what I call active appliances. So let's get right to that social teammate idea. And this is influenced by the work of Cliff Nass and his students 25 years ago, which did dozens of experiments and showed that people did respond socially to robots. They were willing to do that. And therefore, the recommendation is to design robots to be human-like and social teammates. It's a very plausible, attractive, simple idea. It gives a clear model of what design should be like. But unfortunately, I think it's wrong. And Cliff Nass was a dear colleague who sadly died too early at age 55. And we enjoyed many happy arguments over this topic and discussions about this direction. So what I propose is the human-centered conjecture, which says that only humans can be responsible. That makes them a totally different category. Machines cannot be responsible. Oh yes, I know certain legal scholars, philosophers, and AI advocates suggest that in the future, computers will be responsible, they'll have legal roles and so on. I don't think that's going to happen, nor is it necessary. I think the key point to remember is computers are very different from people. They have remarkable speed and storage capabilities. They have large displays that allow them to present information in rapid ways. And so social teammates that collaborate by language, by discussion, by voice interfaces seem pitifully slow compared to the rapid display that you get from a visual machine. I'm going to show you those. Therefore, I would say design tools to be super tools and invite users to fix, personalize, and extend the design. That seems to me the conjecture here, which I see as validated by the success of the 2 or 3 million apps on the Apple and Android app stores, which generally follow these principles. They're human-centered. They give you control. They're, whether it's your digital camera, GPS navigation, or many of the other millions of tools, they are in user control. That's the idea. It's an extension of the principles of direct manipulation. So these are some of the many examples, the digital computers or the navigation choices. This is the right way to make design. These are successful designs. Give users lots of control of the features, let them adjust and make changes. Preview, look in the navigation choices of most mapping services. You choose a destination and a starting point, you get 3 or 4 choices, shows you the differences of how many minutes, and it shows you where they're going to go, and then you choose which one you want, and you get to work. So preview is going to be a central idea, and we'll come back to that. And the other applications of AI, like texting auto-completion, if you start typing University of Maryland, you'll get choices like medical school, or College Park, or Blackboard, or acceptance rate. These are terms generated from an AI machine learning system, but they're previews. They give you a choice of possibilities, and the user remains in control. The design of all these tools gives users control. And spelling correction, similarly. Oh yes, I know that certain things are done automatically because they're reliable and safe most of the time, but you can override them. And then mostly they give you a choice of what you can do rather than make the correction for you. So it keeps control in the user's hand. Translation tools and many other text-based tools that embed AI and machine learning have come to good designs for this kind of technology. Jeff Heer's paper 2 years ago gives a very nice, the paper was in the Proceedings of the National Academy of Sciences, and it gives a very nice set of rules for designing these kind of systems. So we're seeing increasing the use of AI tools based on these powerful interfaces that keep control in the user's hands. That's what I mean by super tools, that the control remains in the user's hand. Similarly, the active appliances in your kitchen, which increasingly are programmable, increasingly have sensors built into them, they take feedback, they learn over time, and whether it's your dishwasher or clothes washer or dryer, these are what I think the future of technologies will be more like. And I'd like to see these ideas put to work in a family of medical devices, in home control devices. Right now, there's too much diversity and control, diversity that complicates control. In my kitchen, I have 7 operated devices, and when I have to change the clock time, it takes a while because they all have different user interfaces. So common user interfaces for home appliances and for medical devices are a grand opportunity for designers. Similarly, the notion of an implanted cardiac pacemaker used to be just implant it and it runs autonomously, but increasingly we have controls on cell phone devices, and then the company, in this case Medtronic, has controls also that give them the data, aggregate data on thousands of pacemakers so they can learn from it and see how to improve them. The Mars rovers are another one, often by some people celebrated as autonomously operating on the surface of Mars. And they do have degree of automation. They can avoid obstacles and precipices. They can move forward, monitor the sunlight, and change the positions of their solar panels, et cetera, et cetera. But there's a whole room full of controllers for NASA's Jet Propulsion Laboratory, sorry. And so I think that's kind of the way to think about it, that don't get too excited about saying it's autonomous, because autonomous has its limitations, and supervised autonomy and a balance in which features should be done. Similarly for drones, drones are often seen as autonomous devices, but actually they're operated, whether they're military drones that are operated from Nevada around the world, or whether they're commercial drones for $100, which you have a control panel in your hand to operate. Yes, they can hover, they can return to base. There's a lot of well-designed automated functioning, but basically it's under your control, and therefore it's your responsibility. So that's what I think is the right kind of design. And, you know, surgical robots, the Da Vinci teleoperated surgery is a quite terrific device. But, you know, the newspapers are very happy to say robotic surgery performs, performs this job. But as the manufacturer says, robots don't perform surgery. Your surgeon performs surgery with Da Vinci by using instruments that he or she guides via a console. And that's the future of this and many other technologies, which is they're operated devices that include some degrees of automation, but also high levels of human control. They have applied the HCAI framework in an effective way. The Bloomberg terminal is probably the best model of what the future holds. Large amounts of visual data. I can't imagine a social robot conveying this volume of information in any way except visual displays. And here, largely spatially stable, non-overlapped window displays, optimized and personalized by the user, that gives them the information that they want in a way that they can perform the tasks in the way they want to, allow them to be creative, to respond rapidly to changing conditions, and also to get recommendations from a highly automated machine learning system. I've mentioned already the hospital control centers that are increasingly part of the spectrum. Still a small number of hospitals, but growing as a strategy. And counterterrorism centers also here shows you people working together, but with a large amount of information that's relevant to individual tasks, as well as shared data on the large screen at the front. So I think that's where you want to look to have visual displays. And I might try to summarize some of the principles. I hope many of you know about the 8 golden rules. It was something I put out playfully in the first edition of the book, Designing the User Interface, and it evolved over the years and became widely used. There are parodies of this on the internet and amplifications and differences, but these 8 rules seem to be good ones for general user interface design. And I would add now 8 silver slogans or silver rules for HCAI systems. You have the opportunity here to store rich data from powerful sensors. That's terrific. Design information abundant displays, provide interactive information visualization. That's really the key, and we're going to explore that further in the section on explainability. Make predictive models visual, just like the navigation system shows you what's going to happen, gives you choices, and then you can initiate the execution as well as intervene while it's happening. Brooks and Safir at the University of Colorado Boulder have shown how effective this is with robotic manufacturing tools. And if you show a visual predictive model of where it's going to go and what it's going to do and how long it's going to take, you get much better performance overall. You want to smooth human-to-human communications, remembering that humans are functioning in a group. And so you want to make it easy for people to ask for help, to involve other people, and collaborate with other humans. You want to create clear control panels. That's how we operate the devices. It gives feedback, informative feedback, like an elevator, like a washing machine. You want to implement audit trails. That's going to become another theme of flight data recorders for every robot. And we want to develop incident reporting sites like the AI incident database at the Partnership on AI, developed by Sean Gregory, already has more than 1,000 reports of AI incidents. And that's what we need to improve the quality of system performance rapidly. Okay, so just to summarize the first part of this talk, the human-centered AI framework here shows you the high level of human values, the individual goals, the design aspirations. We look at the stakeholders and remember the threats always. And we've already explored the HCAI framework, the design metaphors, and after the break, we'll come back and talk about governance structures and the 15 recommendations for that. This is what's going into the book, and that's the website that I've built that describes these ideas, and links to the 4 papers I've published on this topic. For the time being, I have to refer you to the 4 papers as a guide, and until the book is published. I remind you about this 2-dimensional framework of high-level human control and high level of computer automation so as to gain reliable, safe, and trustworthy systems. And I remind you also about the design metaphors, the different ways of thinking. And I tend to lean to the right-hand side, to the super tools, teleoperated devices, and active appliances. But there are lessons to be learned from and improvements to be made on the ideas of intelligent agents, teammates, autonomy, and social robots. There's a nice commentary from a year ago in the New York Times about my position and written by John Markoff. You might want to take a look at that. Again, I remind you the slides for this talk and all these links are available in the slide deck that's posted on the Intelligent User Interface Conference website. And these are the papers I should mention. The first 4 are the ones I had in mind, but the last one is a policy-oriented paper in the National Academy of Sciences, Issues in Technology and Science. All of these papers are freely available online. That was one of my goals in writing these things, is to make them all free and available online. The continuing website where I post information about this tutorial and other videos and resources is there. And I come back to the questions. Aussie, are there questions?
Okay, sure. So there are quite a few questions on our trust in AI. For example, so I don't know the name, but the question is, when do you think that people will be able to self-drive with confidence? And another question by Meek is, how do we protect and promote human expression and our serendipitous moments in an environment of processes where automation is ubiquitous? So these are sort of 2 questions.
Okay. The question of when we will self-drive, well, there's some situations you can self-drive in today. Cruise control is the beginning of that, but increasingly automated on highways that have limited access and better control are already beginning to give you the elements of self-driving. In Phoenix, Arizona, Waymo has a self-driving taxi service, and those things are beginning to come out, and we're learning a lot from each of those. I might say that Waymo's approach is particularly interesting compared to Tesla. Waymo's approach to implementing their self-driving facility in existing car designs. They're not making their own cars, but they provide a centralized control center that supervises and monitors all of them. So I think air traffic control for self-driving cars is what we should expect in the future. I would say the self-driving car community has come to recognize that their early beliefs that this would happen already last year or this year are proving to be overly ambitious. That the number of edge cases or problem cases of bad weather or malicious drivers or adversarial attacks or vandals, these are proving to be difficult problems. And so I think we have to slow down our expectations. I'd like to see self-driving cars, especially if it can improve the safety and reduce the million deaths, 1 million deaths a year around the world from automobile accidents. And so I'm all in favor of this, but I would rather see a safety first car and a self-driving car as our goal. If we start from safety first, we will get to the goal of safety, and we will see how fast we can get to self-driving. I think once you provide a car-to-car transmission of information, centralized traffic control center, you'll begin to have steady improvements in this. And I think the insurance companies, as I'll mention in the next hour, have an important role to play. Thank you. Other question?
Ben, we have an interesting question on supervisory control. So the question is supervisory control a reliable direction forward, given that there are known challenges such as boredom and automation bias, especially in industrial applications?
Yes, certainly there are problems, and I don't think just saying supervised autonomy ends the problem. You have the problems of de-skilling, you have the problems of maintaining vigilance in difficult situations where there is automation. And so there is important need for design of the right kinds of supervisory control and the right kinds of automation, and how the supervisors or the users can get sufficient information to make the right kinds of decisions. And we will learn over time. I think we have to realize that mature applications take years and maybe decades to get quality control. So for example, with automobile airbags, in the early days, airbags saved about 2,500 lives a year, but they inadvertently killed about 200 elders and children when airbags were inappropriately deployed. And it took a while to understand that problem because we did not have sufficient data collection. It took a while till all the emergency room reports could be collected to understand what was happening. And therefore, we've moved the child's seats to the back seat. We put a sensor in the passenger seat. And so we've come to a more reliable and safe system. And so that's what I think we'll see the evolution in many other things. Don't expect perfection, but at every point we want to improve the designs by way of the feedback of data from failures. We need to know where things go wrong. Take one more question and then we'll take a break.
Okay, so this question asks, sometimes AI has high confidence in its prediction, whereas human interpretation is entirely different. Example, image recognition. How do you design HCAI systems that give humans control in such cases?
Yeah, I think we're increasingly seeing, for example, in medical image recognition, cancer, tumors, and so on, there's real opportunities to improve medical care by way of these AI-based recognition systems. But at every point, you want to give that information to a physician. And instead of bypassing a physician, you want to give the data to the physician. And physicians have a growing set of tools, from stethoscopes to electrocardiograms to all kinds of x-rays and imaging devices, and now increasingly AI-based interpretations of these things. So the point is to design with responsibility clearly in mind and responsibility to the physician, that that the AI system becomes a tool for use by the physician, not this naive idea of replacing physicians. One of the leaders in AI, a man I greatly respect, Jeff Hinton, said 5 years ago that absolutely we should stop training radiologists because there would be no more need for radiologists because computer vision systems and were far better at detecting cancers, cancer tumors on imagery. Well, that he's right about the narrow part, but physicians do a lot more than just spot tumors in images. They have a great knowledge and history of the patient. They understand the complexity of the systems that the disease is operating in, and they're much more in a position to make the right decisions. So you want to redesign the tools to support human abilities, not to replace them, not to replace them. I repeat my sort of opening statement about amplify, augment, enhance, and empower. That's what we want to accomplish. All right, I see it's 30 minutes past the hour, so we've gone 15 minutes long to make up for our delayed start, and we'll start again at 45 minutes past the hour. And I'll take a break and encourage you to take a break too, but we'll be back at 45 minutes past the hour. Thank you.
Thank you.
Let me ask the organizers, Ossi and Vijay, if there's any comments you have for me.
Should I stop the recording for 15 minutes, right? I can sort of pause the recording.
Okay.
Okay. I think we're fine. I think everything is okay.
Yeah, it's
Okay.
It's going good, Ben. So we do have a couple of questions. So probably like once the talk ends, we might ask these questions, but they're like good number of interesting questions we have.
All right. I hope you could save them for me and send them to me anyway.
Yeah, I'm saving them.
People are thanking you for a great first session.
All right. Is the sound good and screen? And you can see the screens and all?
Yeah, and I'm live tweeting, so you can go there.
Say again?
I'm live tweeting a bit, so yeah, live tweeting is like taking a picture and putting it on Twitter.
Okay. I'm going to take a little break myself, get a little coffee, and be back here at 45 after the hour. Okay?
Okay, sure. See.
Thank you.
Ben, you might want to sort of turn down your video, like press on the video button on the screen. Start video, like you can, just for the break. Like next to the mute, you can press the stop video. Thank you. Hi, Ben. So before we start, we're resuming. Can we resume the YouTube streaming, please?
Okay.
Just a second. And
Oh,
You
we
should
will
be
start.
ready now for resuming.
Okay, great. So we will start the second session with Professor Tracy Hammond, who is the chair of IUI this year, and she is responsible for all of this happening. And let's just give her a chance to say hi.
Hey, Ben, I just wanted to know that I've been watching on YouTube and I've been really enjoying the talk thus far. Thank you so much for doing this for us in the IUI community and beyond. It's really great.
thank you, Tracy.
And nice to see you again.
Good to see you, right?
Okay. Hey, Ben, I just wanted to know that I've been watching on YouTube and I've been really enjoying the talk.
You need to close your stream, I think, Tracy.
Great, thank you.
And nice to see you again.
Nice to see you, right? Okay. Is my screen sharing on? I think not. Great, thank you, Tracy. Are we okay here?
Looks good.
Welcome back to part 2. I'm getting an echo here. I'm not sure what.
If you have your live stream in the background, you may need to mute that video.
You're right. I suspect that's what it is, but I don't see that. Where? Are we okay here?
Looks good.
Welcome back to part 2. No, I'm getting something wrong here. Getting an echo here. I'm not sure what.
If you have your live stream in the background, you may need to mute that video.
You're right. I suspect that's what it is, but I don't see that. Are we okay? Okay, I think I got it. All right. I think I'm back here. And are you back on to recording?
Yes, and as somebody said, overlapping windows.
Okay, good. Well, thank you for your many questions during part 1. And I heard further questions, or I saw further questions in the chat. So yes, I think, one of the questions was what happens when that systems increasingly recognize and improve their abilities, and then they can propose, say, yeah, I could do that one more automatically. And I think those are really good possibilities, and they should be designed in and designed cautiously. At every point, though, they need to be monitored and supervised to make sure that they're performing correctly, especially with the life-critical and consequential applications. For recommenders, hey, that's a lot easier, and that is a more possible direction. Okay, so here we go. Again, I'm happy to represent the Human-Computer Interaction Lab and University of Maryland, and this time happy to advertise and promote the notions of the annual symposium, our 38th annual symposium. The current director is Nicholas Elmquist, and he'll be hosting the free virtual symposium on May 27th. You can get more information and register at this website. Okay, so I return to the basic notion here of human-centered AI that amplifies, augments, empowers, and enhances people. I just remind you that this is an alternate way of thinking about the future. The story we've heard about the future is that machines will take over, maybe replace us. And these are misguided notions that I don't think will happen. They're certainly not inevitable in my mind. And it's important for people in this community, the user interface design community and the AI community, to get together and develop systems that truly serve human needs, that amplify, augment, empower, and enhance people. And that means control panels, user interfaces, visualizations. Okay, I repeat, here's the structure for thinking about all this. And this part, the remaining hour and 10 minutes, will be about the governance structures and the 15 recommendations that I'm going to make in this time. So the governance structures have been widely discussed. This topic, because of the perceived importance of AI, has become a huge international discussion with more than 400 reports from government agencies, from non-government agencies, from civil interests, civil society groups. And here I just put up a few of them from the early one from Stanford University on AI and life in 2030. And there's just dozens and dozens of these. There's about 400, of which I've read maybe dozens of them, and they're from all around the world, from Europe, from UK, from India, from Asia, and from many different groups. I would like to focus your attention, if you spend time on these. There's two that I think are worth really spending more time on. First is the IEEE's Ethically Aligned Design document. It's 300 pages. But well worth spending time on. And it has many, many admirable attributes, of which I'll go into soon. And it still maintains the idea of the language of autonomous and intelligent systems, which I'm not happy with, but otherwise, ethically aligned design document is really an important one to look at. The second one is from the Berkman Klein Center. It's called Principled Artificial Intelligence, and it studies 36 of these hundreds of documents that make a comprehensive set of recommendations, and they distill that into 8. And ironically, the ethically aligned design also has 8. So here's the 8 in the Berkman Klein report, and this in the IEEE ethically aligned. So accountability is something they both have. They're exact matches. They both want accountable systems. IEEE says transparency, and Berkman Klein says transparency and explainability. Okay. Promotion of human values and human rights, well aligned. Safety and security tied to well-being. So different words, and this is typical in the emergence of new disciplines where people have different languages, different terminology, and they reference different documents. And that's what we're seeing now as the notions of HCAI emerge as a dominant one. And we are seeing the convergence on language, terminology, and references. The more varied ones, human control of technology is asserted strong. That's certainly, you understand, I'm supportive of that. And ethically aligned design says effectiveness, fairness and non-discrimination, awareness of misuse, different phrasing for the same notion, professional responsibility, competence, not exact matches, but somehow related themes if you read the details. And then Berkman Klein recommends privacy as an important goal, and data agency is what ethically aligned design. So the links for these two reports are here. I encourage you, if you're going to spend time, those are two that deal with the ethical AI principles. For the rest of this hour, the governance structures are highlighted by the oval diagram, which many of my readers have really appreciated and want to see it as a poster. Maybe somebody could turn it into a poster and start spreading this around. But we're going to look at 4 levels of governance structure. The team level for software engineering teams, the organizations that they work in and how they could promote a safety culture, the industries that these many organizations participate in, and how they can provide trustworthy certification with external reviews. And then the 4th level of government regulation. The early version of this was described in the paper in the ACM Transactions on Intelligent Information Systems, October 2020. and the URL is there. And again, I've worked to make sure this is free and openly accessible. It's had a large number of downloads already, which are very encouraging to me. And I hope you'll take a look at the paper online and the book when it appears in early next year. We're going to start by focusing on the team issues and what is it that software engineering teams can do. And they're going to be audit trails and analysis tools, software engineering workflows, verification and validation testing, bias testing, and explainable user interfaces. And I'm going to go through each one of these, but these are recommendations about how to build reliability into systems by software engineering practices of teams. So teams might be 5 to 15, 50, or 100 people working together on a particular project under a single leadership. And there are things that team members, the technical people who implement AI algorithms and design user interfaces can do. So the first one, and you can see I put it up front because it's a really important one to me, audit trails and analysis tools. And I've said this before, but I'll repeat: the flight data recorder for every robot. Flight data recorder for every robot. Just as in air traffic systems, civil aviation has become a model of safety because of the flight data recorder and the cockpit voice recorder, which allow the forensic analysis of airplane crashes and other kinds of failures. So they were originally designed, starting 50 years ago, as retrospective analyses of failures to be able to understand how things go wrong. But they've grown in their use because now, with kind of analysis that's possible, you can understand the near misses. You want to understand the places where the pilots recovered from a near disaster. And so that became a big opportunity. MITRE Corporation has the responsibility for analyzing these. And so they've begun to develop the strategies that you could detect when near misses have happened and be able to celebrate the performance of the crew. The second unexpected benefits of audit trails were analysis to support preventive maintenance. And that turned out to be a big win in that some of the aircraft are used very frequently. And so their failures predict the performance of the aircraft for the entire fleet. And that allows the maintenance staff to engage much more effectively in preventive maintenance. Now, this idea of an audit trail or a product log or a flight data recorder seems natural and obvious. And in the industry world, the Robotics Industry Association, this is widely accepted as important, necessary, and beneficial. On the other hand, the research community has actually rejected this idea. I found lots of patents about flight data recorders, but very few research papers, very difficult to find research papers. And when I spoke to 4 conference organizers and 1 journal editor and asked them about this, they said, no, they were not interested in that idea. And that troubled me. So we do need to see a change of attitude. And I hope many of you who have the opportunity to work on systems will build these. Now, we're not talking about every system. Research systems and novel systems don't need this, but once you think about implementing a system for widespread use, you should be thinking about a flight data recorder for that system. Okay, that's the first one. Second one, software engineering team practices and the workflows. One example is Microsoft's workflow for machine learning, where they propose this 9-step model of how you go about building AI machine learning systems. And look at that. Steps, first, setting the requirements. We've talked about that before. That's a starting point for every project. Studying the users, the stakeholders, the managers, and understanding what the requirements are. Then the data collection, data cleaning, and data labeling. So they have 3 distinct steps. That shows you how important it is to do the study of the data and make sure you get the data right, because bad data produces bad models. Feature engineering, model training, model evaluation, model deployment, and model monitoring. Their paper in International Conference of Software Engineering from 2019 is a good model to follow, is a good paper to follow. Other companies, Google's workflow for algorithmic auditing has 5 components: scoping, mapping, artifact collection, testing, and reflection. And so that's another example that you can take a look at. Let's see. I should say also that other companies like IBM have also proposed these workflows and papers and work that they've done. You can read these papers in the open literature. So I encourage you to do that. The third issue for team practices are verification and validation testing. So you're going to check for the bias in the data. You're going to check for the validation and verification of the systems. And there are typically 5 kinds of testing. There's traditional case-based testing, by which you have a set of test data cases and you have expected outcomes, and you build a database of these. There may be hundreds or thousands of them, and those expand over time, but you test the system to make sure it delivers on the cases you know about and produces the results that you expect. Metamorphic is another idea, and it's a quite clever one, which says, instead of, in order to relieve you of the effort of creating all these cases, there are certain principles, like if you have a recommender system for products and the user changes the maximum price they're willing to pay from $60 to $100, that should reduce the number of results, and all the results should be the same category. That should be same as ones that were included in the $60 limit. So there are increasingly clever strategies for doing metamorphic testing. Differential testing says, as you make updates, you compare performance on version 27 with performance on version 26. It's not a perfect way, but it does allow you to do a lot of testing without having the great effort of writing all the cases. There's also user experience testing as part of it, and the growing set of notions of red teams, where there's an adversarial team that comes forward, and their job is to find the flaws. And so red team strategies, which were developed from cybersecurity ideas, are becoming increasingly used in AI applications. There's lots of work going on in this area. Microsoft's data sheets for data sets, Google's model cards, IBM's fact sheets, all are ways of recording information about these systems. Again, this is not for every system, not for research systems, but when you're a large bank putting out a new mortgage system, or a manufacturing corporation building a robotic system, the idea of having a clear documentation of what's in this version of the system, what are the data like, become really essential. These ideas have grown rapidly in the past 2 or 3 years, and the documentations are best seen on the website and some of the papers that have been published. I think it's really admirable that these 3 companies and others have moved towards these proposals, which are gaining acceptance and show the maturation of the field of AI machine learning as they attempt to document in a substantive way what's going on. And then the other strategy for reliable systems is to track the history of bugs, of problems, and concerns. Again, cybersecurity history has a good model here. MITRE Corporation, again, keeps an attack profile of 300 ways in which cybersecurity systems can fail. And so that's the kind of database that's really valuable for everyone in the field. And this can be replicated at each level of company. And there's good evidence that companies that keep a, for example, a one-page sheet of the typical bugs that users run into, those companies do better. They have, better performance in the development of their tools. Okay, number 4. Again, strategies for software engineering teams to work on. Bias testing to ensure fairness. This is really an essential and important and growing case and aspect of design of systems. In an early paper in 1996, Batya Friedman and Helen Nissenbaum described 3 forms of bias: pre-existing bias based on existing belief systems and implemented in software, then technical bias that comes up because of technical decisions, like in an organ donor application, it's inappropriate to list potential donors alphabetically because you want to order them in terms of the appropriateness of the match. Similarly, for airline recommendations, you want to make sure you make the recommendation on values that the customers want, not because some company may have paid more to get their flight higher up on the system. Emergent bias is related to what's become known as distributional or context change bias, when the shift happens when a machine learning algorithm tested in one circumstance becomes applied in a new circumstance. Things may go badly. There's a remarkable paper from Google, from 40 engineers of Google, just in the past year, about under specification. There are reports on repeated experience at Google where systems that worked in the lab and during development failed when put into the real world. And that became a really important issue. And it's really a sense of humility that we have to take to understand that what we test in one circumstance may not work out as well in other circumstances. Ricardo Baeza Yates catalogs many of these emergent biases in web systems in a very nicely done paper in the Communications of the ACM in 2018. Now, what you've certainly seen, I hope you've all seen, the concern over facial recognition, especially what's called intersectional bias. And Joy Boulamwini and Timnit Gebru had early on recognized that facial recognition systems did poorly on women and poorly on Black faces. And they did even worse on women, dark-skinned faces. They documented this with several of the commercially available facial recognition packages. And that paper had a huge impact, and it produced immediate results of improvements in facial recognition over a very short time, a few-year period, from these commercial tools. Yet still, facial recognition is known to be problematic and biased. And I just do strongly encourage you, a recently released film called Coded Bias, now on Netflix, but available many other sources, is a full-length documentary about the work of these 2 women and others who contributed to an understanding of these problems. It's a really nicely done film, and it's just out in the last month. Finally, IBM's Fairness 360 Toolkit gets special call out because it addresses these issues and addresses the ways to improve bias. I think I'm a little optimistic to ensure fairness. I said, call this bias testing to ensure fairness. And I think I'd rather rephrase that as to improve fairness. I don't think you can ever attain full fairness. And as some of you will raise the question, of course, what seems fair to one set of designers or managers may seem unfair to others. These are difficult ethical issues to resolve, but at least we need to be aware of how systems can be unfair to one community or another community. This is an important issue. It's gained a lot of attention, and I think there is good progress. The Fairness, Accountability, and Transparency Conference from ACM has been an important space for discussing these issues. Okay, now we're going to spend a little more time on this one, explainable user interfaces. The general and prevailing view in the explainability community, and it's become a big topic in the last 5 or 6 years, is that retrospective explanations are what are needed, and the discussion is whether they're local, very specific approaches, or global, describing the whole process. These retrospective explanations, often called post hoc explanations, are what are widely discussed. But I increasingly came to be concerned about this approach, and I felt that there was a real opportunity in a new goal, that is to prevent the confusion and surprise that leads to the need for explanations. It seems to be a much better approach to prevent it than to try to cure it. So this leads to the idea of prospective user interfaces, sometimes called anti-hoc interfaces, anti-hoc, and these are interactive, visual, and exploratory. Let me show you what I have in mind. I might say first that, you know, in the whole world of explainable user interfaces, and I've been immersing myself in it in the last few years, and especially while writing the book, I had a great deal of difficulty of finding user interfaces for post hoc explanations. I looked at, I would say, at least 100 papers, and they were always describing post hoc explanations, but rarely showing them. I finally found one example from Margaret Burnett that I thought was a good one at Oregon State University. But in general, that's the only one I found so far that I think is reasonable. I think it's really difficult to have post hoc explanatory systems. Okay, so what do I mean? Here is a typical example, again, a simplified one about mortgage-based system. So the mortgage amount you request, $375,000, your household monthly income, $7,000, liquid assets, $4,800. And now you submit, and you get a response that says, we're sorry, your mortgage loan was not approved. You might be approved if you reduce the mortgage amount requested, increase your household monthly income, or increase your liquid assets. That's pretty much considered to be a good post hoc response. And again, a simplified situation here, but to me, it does not give a clear enough message of how close you were and what you could do to change things. And so I propose a more interactive, interactive system that would allow the user to move a slider to change the amount they requested, move a slider to explore, to see if they could increase their monthly income, and if they got more liquid assets, would that help? And their score would go up and down, and they need that level, the green bar, to get approval. And they can see in an exploratory way what they need to do in order to attain the goal. That's serving human needs. That seems to be a more compelling approach to doing it. So interactive, visual, exploratory is what I'd like to see for what I call prospective user interfaces. Now, people have found ways to do this already. A delightful one I encourage you to do it. It's just fun, called witchbook.net by a British set of librarians, a wonderful group of people I've been in touch with. And they have a set of sliders, and you can just slide to choose, do you want books that are funny or serious, sexual content or none, optimistic or bleak. And as you move the sliders, you get an update in the choices of books that are recommended. And this has been done in about 24 experiments and other systems, like a news recommender, where you can move sliders for politics, entertainment, or sports. 3 sliders, and as you adjust them, the 9 recommendations change rapidly, incrementally, and in response to your work. And that gives you a better understanding and allows you to do exploration. Another nice one, Katriane Verbet and her team used 5 of the 14 variables in the Spotify music rating: acousticness, instrumentalness, danceability, valence, and energy. And as you adjust them, you get to see different recommendations of music to watch. Similarly, the OECD's Better Life Index gives you a bunch of sliders, and you can find the countries that are strongest for each of these. So these recommender control panels seem like the right way forward, and it's well aligned with the ideas I've talked about already. And I bring back the example of GPS navigation, where you get before you go, you get a visual recommendation or 3 recommendations, and then you choose, and then you get to see a preview. So I was highlighting this earlier as overview first, zoom and filter, then details on demand. But I think a new principle, a new mantra would be helpful as well. Preview first, select and initiate, then show execution. And as I said, there's growing evidence that this is the winning strategy. Brooks and Saphir at University of Colorado Boulder showed that to be a winning strategy for industrial robots. And we see it applied so successfully in GPS navigation, and I believe other circumstances as well. So I will recommend preview first, let you select, users can select and initiate, and then show the execution so that the users can monitor it and decide if they want to change it along the way. Again, this new form of mantra asserts the centrality of human control over these AI-based tools. And that's what I think we need overall. So that's the visual previews. Now, I'll pause here. That's the first of the 3 sections here. This was about recommendations for design for teamwork. So Ossi, let me turn to you and ask if there are questions.
Sure. So there was a question that was asked right at the end of the last session by Andrew. Haven't recent studies shown robotic surgeons to have better outcomes than traditional methods?
Yes, not entirely, but robotic surgery, which is not an autonomous robot, but a physician operating a teleoperated device, often has better outcomes for certain kinds of surgery. A year ago, I had a small surgery in my stomach area, and I had a choice between the robotic surgeon and the human surgeon. And it turned out to be, for a variety of reasons, that the surgeon without the robotic tool was a better choice. So I made that, but I would have been happy to do the robotic-based surgery because it's not the robot doing it, it's the physician doing it. Ossi?
Yeah. Vijay?
Yeah, so we have another question. Have you considered an AI learning agent's ability to learn new capabilities and self-assess their mastery? What policies might be needed so that a super tool might declare, I can do that now, or the situation has changed and I can do that now?
Absolutely. That's a good idea. We have that in lots of systems. Web crawlers have been doing that for decades. They traverse the web and they report back about what they find that's changed. And that allows the operators to adjust the behavior for future web crawling. And systems that give feedback, absolutely, we want that. But we want to make sure that the feedback stays within range of performance. Similarly, even things like dishwashers and washing machines have sensors that monitor the cleanliness of the water, the temperature, and they can control what's happening. And then the next step is to report that, and then there may be ways to improve performance along the way. I think also the Google Nest machine learning tool for thermostats are another way in which you want to embed machine learning in these systems, but you want to have them under human supervisory control.
Nice. Yeah.
Yeah.
Thanks, Ben.
Yeah.
We have another question. Given the misconceptions of AI, can people ever trust an AI, or will they always treat it as a form of magic? Will false mental models lead to an abandonment of rational thinking about devices?
I don't want to abandon rational thinking. I do think we will have increasingly powerful tools to use. And as we gain trust by seeing them perform increasingly well, then we will use them more. The important thing is that we need to have the data that gives us the trust. If self-driving car companies guard the data about the failures, then I won't trust them. Shut it down. If we don't know if it's reliable or safe, shut it down. If it's out of control, shut it down. And we need to make sure that human responsibility is there. As I'll say in the next section, insurance companies will play a role here in building our trust, because if we have insurance, we're more likely to trust it because we know that there's a potential for redress in cases of failures. Let's take one more.
Okay. So speaking of intelligent user interfaces, in addition to design guidelines, how can we support user interface designers in designing AI applications? Do they need new prototyping tools?
Well, I see nothing wrong with design guidelines, and I think they need to be extended for machine learning. I offered my silver rules to accompany the golden rules, and that's one contribution, but I would say guidelines for AI are a good idea. In fact, I would like to recommend Google's PAIR, People in AI Research Team, their PAIR guidelines document, 50-page, well-written guideline document, which has many examples in it. That's probably a good place to start. And similarly, Microsoft's 18 rules, and they have model cards with these 18 rules. And IBM as well has a set of guidelines documents. I think that's the way it will go. And we should remember that these systems will be designed by people, and people need to monitor their use. They're not so radically different from previous systems. I don't buy the argument that says these are so different that previous previous rules of working are negated. We need to expand them, refine them, and change the technology changes. All right. If there are more questions, please.
Just more relevant, one more.
Yeah. Okay.
So there's a question that says that preview first, selection and initiate, then show execution is a compelling metaphor, but it's hard for me to see how it might apply to domains where the unit of analysis is hard to summarize. For example, I'm thinking of automated content analysis systems where previews of expected outcomes are hard to generate due to the diversity and potential vandalism, for example.
Wow.
Apply this metaphor in these kinds of complex domains?
That's really interesting. I don't have a good answer for that. Please send me that as an email. Let me think about it and see. I don't think that this preview idea is good for every application. It's one where, you know, there are typically physical actions in a time-constrained way. But let me think more. I don't have an answer for that one. Please, someone send me an email for further discussion. I think I'll have to move on here. The second category of recommendations has to do with building a safety culture inside organizations. And so these are for a large company, which might have dozens of software teams. So I've given advice for the software teams, but there is also responsibility for the organization leader to build a safety culture. That notion, which grew partially out of medical applications, aviation, transportation, means an intense focus on safety. So the 5 recommendations here are: the first one, is the leadership commitment to safety. And there are a bunch of theories about how to develop safety. Charles Perrow's normal accident theory, my favorite description here, imperfect though it is, but still normal accident theory says that accidents are inevitable. He's a little bit too negative maybe, but he does make a good case that accidents are quite normal. And if we ignore them, it's at our peril. And we'll do a lot better if we understand that accidents and failures are likely to happen. The contrasting theory was high reliability organizations, and maybe I should say resilience engineering. Each of these, again, symbolic of emerging fields of discussion where we have 4 different languages, 4 different sets of references covering more or less related issues. I chose to focus on safety culture, and that happens by leaders taking a set of steps. One is repeated public statements, plus vision statements, mission statements, or whatever you like, to describe their strong commitment to safety and their recognition that in transportation, medical care, military applications, and many other places, safety culture is really the competitive edge. That if your company, is your organization, your products are seen as emerging from a safety culture, you're likely to gain more customers, and you're likely to have better products, and you're likely to have safer products, and you're likely to have fewer injuries, and it's likely to be cheaper, ultimately, to have a culture of safety, because you'll avoid the kind of perils that happen in other circumstances. Now, this means significant commitment in budget and hiring of the right people and spending time in rehearsing for dangers and for avoiding failures, and then collecting the data about near misses. So safety cultures typically have an openness about failures. Hospitals will have typically a monthly meeting of a committee that reviews the failures and the near misses and makes recommendations. There might be annual reports on safety, the number of failures and mistakes that were made. And important thing to remember is this becomes a competitive advantage. Yes, I know there's a real danger that leaders, and in times of financial stress and difficulty, will lighten up on safety culture in order to make their bottom line favorable to shareholders. But I think increasingly there's a recognition that there's a competitive advantage to a safety culture. So the first part is the leadership commitment and doing that by a set of actions. The second part is hiring and training oriented to safety. Job notices for the company will consistently emphasize safety as their goal. The interviews with new hiring candidates will focus on safety. Training for safety will be a big part of newcomers, and then retraining and simulated disasters. Some hospitals run simulated disaster of mass casualty events, and many organizations, especially military, continue to do training and spend a large amount of effort. Similarly, airline industry, which is so respected for its safety record, makes a big commitment in this topic as well. Next, the extensive reporting of failures and near misses. There can be public reporting and internal reporting, and these may differ sometimes. It's understandable that a company may wish to keep some information internal, but the more they report publicly, the greater customers are likely to accept their reports, trust them, and buy their products or services. I think admirable examples in mature industries, the Federal Aviation Administration has a detailed failure reporting scheme, of course, that tracks every incident, but there's also a website by which those active in civil aviation, pilots or air traffic controllers, or the general public can report incidents that they have seen. Similarly, the Food and Drug Administration has an adverse event reporting system which tracks thousands of reports from pharmacists, from clinicians, nurses, patients about things that went wrong with a certain medication. And from that data, they know what to investigate and how to make those medications safer, and know for which communities they are safe and where they're not safe. A growing idea in this community is the idea of bug and bias bounties. That is, you pay people if they find bugs. Google has paid, I think, a total of $3 million over the years to people who have reported bugs in their systems. And now there's a growing movement to have bias bounties. If you can show bias in systems, companies will pay you for that. AI incident database is, I mentioned Sean Gregory at the Partnership on AI has put together this database. You can take a look at it, this link, but it already has more than 1,000 reports of AI incidents. And that's the kind of thing we need. And I mentioned earlier the tesladeaths.com website that does catalog the number of deaths in Tesla cars. Now, remember, these are based on public reports in newspapers around the world. And so it's an incomplete report, and we don't know how many of these deaths were caused by the autopilot driving system or not. So these are, emerging areas, but you and your companies or you and your research could distinguish yourself by developing these kind of incident databases, which will be beneficial to insurance companies, developers around the world, and other organizations, journalists as well. Another signifier of safety culture is that there are internal review boards, as I mentioned, monthly review boards at hospitals, and also discussions of future plans. Regular overviews, public reporting of these things, oversight group gains experience over time, and the idea of audit committees. Audit committees emerged from financial accounting for review, and they are developing as a way of evaluating AI systems. Maybe Microsoft's AI review committee system is a model here, and Google also has described its process for developing internal review boards. And finally, the alignment with industry standard practices is another way to improve the safety culture. The International Standards Organization has a technical committee on robotics that's quite active, and also in the US, the Robotics Industry Association, strongly devoted to developing standards and practices. And we're seeing the arrival of organizations like Underwriters Laboratory and Consumer Reports that are getting active in the AI world of things and machine learning. Maybe most notably for this community, the P7000 series are about a dozen standards that the IEEE is forming committees around. You can join these committees, you can see the reports on their websites, but they have separate standards committees for ethics, for well-being, for transparency. I got involved in the transparency one and found it to be a pretty interesting case. And there are those who believe that the best way to assess the reliability, safety, and trustworthiness of a system is the degree of transparency it has. And this P7000 series standard is a standard for assessing the transparency of a system. How well does an organization report all the things I've been talking about here? The failures and the problems, and how open are they? What form of documentation do they have for their systems? And finally, I might mention the capability maturity models. This grew out in the 1980s from the Software Engineering Institute at Carnegie Mellon University. And it was a 5-level maturity model for software engineering practices. And US government and military procurements were often tied to these capability maturity models. So a company could assess itself as being at level 1, 2, 3, 4, or 5. And if they were at higher levels, they would be eligible to compete for more projects. The idea of AI capability maturity models is beginning to grow in medical applications. And so I think there's an opportunity there as well. So in this case, we're not looking at the AI system, but we're looking at the process by which a team or an organization develops and uses the mechanisms I've described here, that they have bias testing, they have validation, verification testing, they make things public. And all of those are indicators of maturity models. Maturity models are often tied to capacity to measure and to replicate behavior, that teams should then have a standard way of going about their work, of regularly assessing their abilities and reporting on the problems they face. So that's another opportunity. Again, this is for management strategies within an organization. So those are the 5. In that case, I'll take a pause here and see if there are questions, and let Ossie lead the way. Again, I prefer to focus on the questions about safety culture and the way organizations can guide the design and development of systems.
Yeah. Hi, Ben. We have a couple of questions, and this question is on explainability. So the question is, explainability is either discussed as a preview before making decisions or post hoc explanations as in recommender systems. But how important is real-time understanding, especially in dynamic interactions?
In dynamic and real-time interactions, I think they're essential. And you need a situation awareness display that lets you see not only what the current state of the machine is, but also what it will do in the coming minutes ahead. A good example of this is in large ship navigation systems. The captain can enter a destination, and then the shipboard system will show the path that the ship will take, navigating away from obstacles or going through narrow passageways and avoiding other ships and other problems. And it shows the expected path with various waypoints that let you know you'll be at this waypoint in 22 minutes and that one in 43 minutes. And that will give the captain the chance to change the decision if he or she wishes to do so, or to stick by what it says. So I think while these are difficult, they seem to be really essential, especially in life-critical and consequential decisions. Similarly, stock trading transactions for the large traders, they will watch the execution automatically of a large number of trades, and they'll be able to see how it's going along the way and then intervene if they wish or confirm it. And that's kind of a standard practice. So I think we'll see that in increasing number of cases. So it all relies on a control panel and visual displays that show, again, I repeat, current status and expected and previews of what the future will bring. Thank you.
Thank you, Ben, and thank you, Vijay. And also there's another question. Do you have more information on capability maturity models?
Sure. I mean, there are many papers and websites about it. I discuss it in the book and I discuss it in the paper that's freely available now on bridging the gap between ethics and design and practice. So those are available. There's whole communities that are based on it. I should say there are skeptics also who question its value and benefits, that suggest it's more expensive, requires more effort, has more impositions on organizations. But there are some cases where it's required by contracting agencies and the benefits seem to be in place, that this notion has maintained and gained strength over 30 years. And I think we'll find a new revival of AI capability maturity models.
Yeah, thanks, Ben. So we have another question. So if you had to add a fourth law to Asimov's 3 laws, specifically for HCAI, what would it be? And where would you place it in priority or rank? So to refresh, the laws are do no harm, obey human orders, and protect itself.
Yes, Asimov's 3 laws of robotics from 1942 were really influential and very clever, I have to say. It was nicely done. But I would say I'd recommend you to read Frank Pascal's book called The New Laws of Robotics, by which he offers a set of 4 new laws of robotics that include such things that, AI systems need to identify themselves as AI systems. They cannot be invisible or deceptive. So I think that's, an important principle. And while Asimov's rules are a wonderful sort of high-level notion, Pascal gets us closer to design principles. And I think those are good guidelines. Thank you.
Thank you. So there is another question.
One more, yeah. Yeah.
A question about, I love the idea of interactive UI for mortgage decision explanation. However, wouldn't this motivate users to lie about their financials to hack the system?
They can always lie about systems, always lie about their data. They're bound legally and contractually to not lie. But I don't think that giving users an understanding of the model will increase their potential to lie. If that is true, then you need to increase the requirements that truth be told, and you need to have evidence and documentation for it. Yes, there are dangers in every strategy we take, and I think you have to balance the dangers with the advantages. Okay, save. If there are any more questions, we'll have a point at the end. As 20 minutes, less than 20 minutes left to go. So I want to get on to the last categories of industry-wide notions of trustworthy certification by external reviews. Google and many other companies say, we have a very careful safety culture in our organization, just trust us. And I can agree with that, and I'm really impressed by what my friends and colleagues at these leading companies have done and how careful they are. Yet, having external reviews and certifications is demonstrably a big advantage. We know that there's real payoffs in that. So let's take a look at this notion of trustworthy certification by independent oversight. And the categories here will be accounting firms and insurance companies, non-governmental and civil society organizations, professional organizations, and we'll look at government interventions as well. So this notion of trustworthy certification and independent oversight, not by the developers, but by someone else. So it's akin to the red team idea of having someone other developers to take a look at this. I first proposed this in November 2016 in an article in the Proceedings of the National Academy of Sciences. And I made 3 categories of independent oversight. The first is planning oversight. The second, continuous monitoring during usage and production, and then retrospective analysis of disasters. So we'll take a look at all 3 of these. And important issues in designing independent oversight is degree of independence. So this becomes controversial. Facebook set up an oversight committee, but they didn't call it an independent oversight committee because it's quite closely tied and supported by the company. It has certain financial independence, and it's possibly a good step, but it's not the full degree of independence. Independent oversight might be like the National Transportation Safety Board or the Federal Reserve Board. Such oversight committees might have subpoena powers to require business executives to testify and others to provide data. And then they have power to enforce the recommendations. If an organization, if an oversight committee makes a recommendation, gets a lot of publicity, but nothing is done, that's a failure. And so you want to be able to promote the notion of enforced recommendations. Now, I should say also, independent oversight has been a success story, largely, again, imperfect, but a success story in financial auditing, where the gap rules of financial auditing have become standardized across every company that's publicly listed in the US. Securities and Exchange Commission in the US requires this, and there is an internal audit committee in companies that review their financial reports, but then there's a requirement for an external audit committee to do reviews of the financial reporting. And it's generally agreed that this has been a great success story with some notable failures like Enron or Qualcomm. But, you know, that's what happens. That's the reality we live in. There are no perfect solutions. Okay, so let's take a look at these three forms of oversight. Planning oversight is exemplified by this zoning board meeting. And here a builder is proposing to make a certain building, an office structure, a shopping center, or whatever, and the community gets to discuss it, and there's an adversarial approach, and people can complain about it. There may be revisions to the plans, and then it can get approval to go ahead. The building gets built, and then the inspector arrives to verify that the builders have adhered to the building code. And the building code is a huge 30,000-page set of rules about fire safety, electrical safety, many, many, many other features of modern construction. And this gets refined over time. But the inspector comes by to verify that the builder has built the building according to what's been promised. And then the builder gets a certificate of occupancy. And then your insurance company will come along and say, okay, we'll insure this building. So planning oversight's a good idea. It forces anyone proposing a major system, again, not a research system or startup company, but if a major company like Bank America, which has admirable efforts in machine learning and AI, wishes to do a new mortgage approval system, they should propose this publicly in advance to allow discussion. And yes, this could slow things down. On the other hand, it could speed things up and avoid, other problems. And so zoning boards have come to be widely used in construction industry. And I think equivalent forms could be constructed in different industries, whether it's transportation, medical care, and so on, to provide planning oversight. Continuous monitoring is here the Federal Reserve Board in the US. Continuously monitors the way banks perform and makes sure that mortgages are granted on a fair and equitable basis. And so it is expensive. Similarly, the Food and Drug Administration continuously monitors the meatpacking industry, the pharmaceutical production industry. And so that is expensive, but it is known to be effective. And finally, the last one is retrospective analysis of failures. Here, the NTSB arrives to inspect a recent airline crash. And the NTSB, which is a really interesting organization founded 85 years ago inside the US government, but it is not part of any of the departments of the government. It's funded by Congress independently because it would examine the workings of possibly every one of the agencies or the departments of the US government. I might say I should apologize here. My examples are highly tuned to the US, and I know we have an international audience, but these are examples that I know well. And if you have further information for me about international bodies that are performing related tasks, please let me know. Anyway, retrospective analysis is the third category. It gets a lot of visibility and public attention, and it has been shown also to be effective. Okay, so there are approaches to certification. And I've mentioned one category, which is accounting firms that conduct external audits. And the big four accounting firms, international firms, Deloitte, Ernst & Young, KPMG, and PricewaterhouseCoopers, which do financial accounting, might step forward and do AI audits as well. And similarly, consulting companies, Accenture, I've been in touch with them. They are pursuing this actively. Boston Consulting Group, McKinsey are also active in this space, but they could play a role in developing this. And other smaller companies as well. There's real opportunity to grow the notion of companies which do AI auditing for a fee, because companies will see that their products and services are much improved by these kind of audience. And the benefits of this kind of auditing is that the experience that these auditors have across companies adds value to their work. Secondly, insurance companies, I've mentioned briefly a success story, more or less, in construction, healthcare, transportation, and so on. And the idea of building codes for building code. Carl Landwehr's series of papers describe how to make code for building code. A very nice idea. And the question is how self-driving car insurance premiums could guide safety. If these companies, insurance companies, Travelers Insurance has stepped forward in this space, and if they had a higher premium for self-driving cars, that would send a big signal to the industry that they need to do better. We don't really know for the moment if self-driving cars are safer or less safe than human driving on a passenger mile basis. If insurance companies made lower prices for self-driving cars, that would accelerate interest in self-driving, or as I prefer to call them, safety first cars. I should say, of course, insurance companies are not always trusted, and skeptics don't believe that insurance companies are trying to do the minimum to pay out for claims. On the other hand, many claims, not all claims are warranted. So insurance companies are a potential opportunity here for improving AI machine learning systems. The next category is non-governmental and civil society. I've mentioned a few of those already. The non-governmental organizations already active, and Joy Buolamwini's efforts through the Algorithmic Justice League show success in the area of facial recognition. It's a great story of how academic researchers saw a problem, studied it carefully, and actually produced a dramatic change in industry efforts. Professional organizations, I've already mentioned the IEEE's P7000 series of standards, the IEEE's Ethics and Autonomous Intelligent Systems. There's other groups, Montreal AI Ethics Institute, which has early on been active in this area. The OECD's AI Policy Observatory and other related ones are another good area. ACM's Technology Policy Committee, which I encourage you to participate in. I'm a active member within several of these. They have an AI and algorithms subcommittee that I'm part of. And then we have groups like Partnership on AI, funded by big companies, but hundreds of partners to make that work. There's also university research groups. Here I cataloged a few of the ones whose names were used phrases. Again, we see the still growing awareness of the language. We have human-centered AI as some of the names, but others call them ethics of AI or assured autonomy or whatever. Humanity-Centered Robotics Institute. So there's different names. If you know of other labs that are focused on these areas, please let me know. I can add them to this list. We have a growing list and a website to keep all these things. Finally, come to the topic of government regulation. And in the US and elsewhere, regulation is controversial. Industry claims often that regulation is a bad idea, it slows innovation and can't keep up and should let companies do their thing. On the other hand, there are other examples where regulations have accelerated innovation, usually described as examples for automobile fuel efficiency and automobile safety. It was government regulations that accelerated dramatically the innovations in those two areas. And so regulations can be very positive and effective. In the US, the atmosphere in the past 4 years has been to limit regulations, but that may be changing. In the US, we have various efforts to regulate from I've mentioned the Federal Aviation Administration, the Food and Drug Administration, the Federal Trade Commission, National Institute for Standards and Technology. All of these are getting involved in these issues. I'm a member of a committee at the NIST about assessing trustworthiness of AI. We held a workshop a little more than a month ago, and they have a continuing effort in publishing papers. Their paper on explainability of AI is well worth reading. Its revised version is almost 60 pages, but a good comprehensive review of this area. In the European Union, the GDPR, General Data Protection Regulations, has been an influential effort that's changed a lot of the way data is used, especially for AI and machine learning. Its requirement of explainability has driven a great deal of the interest in research and explainability. The OECD has a strong set of principles of HCAI, and the United Nations AI for Global Good Summit is another place to look for interesting information. And so we get to the end, and the summary, again, I return you to this slide, which has the 3 ideas of this tutorial, the HCI framework of 2-dimensional thinking and design metaphors that are super tools and active appliances, and the 15 governance structures that could be helpful. There's the model, the 2-dimensional model, I hope you'll remember. And you can take a look. Again, the slides are on the website. And the design metaphors that I contrasted, there are benefits to thinking about intelligent agents and autonomy, but I prefer the super tools and active appliances and teleoperated devices as my design metaphor. But there are lessons to be learned. There are success stories. Social robots haven't worked out, but notions such as voice user interfaces, Siri, Alexa, are great success stories. Again, imperfect, but still success stories. And there's something to be learned about that. I don't think of Alexa or Siri satisfies anyone's definition of social robots, but there are still good ideas that come from that. And I would say there's also still benefits. I haven't talked much here, but some of the pet robots for dogs and Paro, the seal, for patients with mild or moderate dementia. These are proving to be effective. And so we're seeing the development of that and their rapid growth in the field. I've talked to 2 of the companies that are designing newer, lower cost dogs. Both of these were dogs and cat, furry dogs and cats that seem to be satisfying. So there's some mild stories, but I don't see a large future for humanoid social robots that will walk into the room or follow you around in an airport. I just don't think there's a future for that, but I'm ready to be convinced that there is. So look around, but just be aware that many of these systems have failed. Curie robots, Jibo, Cosmo have all failed in the past couple of years. And there's plenty of money around for investing in these. Don't be confused by Sophia, the social robot. It's a wonderful publicity stunt and it's entertaining. It's lots of fun, but I don't see that there's a large future to Sophia-like characters. Yes, people enjoy robots. It's great for kids to learn about them and to program them. I bought a few of them. I've tried them out. It's really impressive what you can get for even under $100. You get a pretty nice robot that's programmable, and there's some values to that. Okay, and my oval diagram I return to here as a governance structure. So my closing comment, again, the 4 or 5 papers that are on the website and all available for free. Please take a look at them, send me your comments. And we've 2 weeks ago started a Google group on human-centered AI. It's now set up, so if you go there, you can apply for membership and we will approve membership in that. So that's another way to keep up with what's happening. And we've started a website. I haven't posted that link yet, but soon we'll have a website on that as well. And a final reminder, please join us for the annual symposium of the Human-Computer Interaction Lab at University of Maryland. And I will again do a 3-hour tutorial like this one at that symposium, all free and virtual and open. So look forward for you to join there. And I close. We've a little over time, but I'll take a few more questions for those who can stay. Thank you very much for this opportunity. And I hope these ideas are useful. Please do get in touch with me by email and let me know if you have fresh ideas or differ or want to steer me to something that I don't know about yet. So there's lots happening. It's changing very quickly, but I'm excited. I'm passionate. I believe that the future is human-centered. So let me stop there.
Thank you very much for a great talk. We all had a great time. And we have a few questions. And actually, I would like to go with a question myself. I wanted to ask you about some temporal drift that I'm afraid that's going to happen in time with the human-centered AI. And I'm going to your example on insurance companies and how much they would charge for automated cars. And I believe that at first they would, charge more for some of the people and charge less for some of the people. But with time, people will drive less and less and less. And the whole concept of person has more control and knows better what to do than the car. Some people have more experience, will just be moot in a way, won't be relevant anymore because people will not have experience. So we rely more on,
I guess I need to push a little bit to clarify that. Yes, I think as automation increases, people de-skill. They lose their skill maybe, and the automation gets better. Now, we may say, calculators are a bad idea because people lose their ability to do mathematics on their own. And anytime we automate, we're potentially going to de-skill or lose skills. People's capacity to memorize. Plato complained about printed books because people would no longer be able to memorize as well. So yes, there are certain skills we may lose. I'm not too unhappy about losing the driving skill. And, it may be that we can only drive, we'll think of time 50 years down in the future when only self-driving cars will be allowed on highways, and we may go to special places for driving on mountain roads and have the experience of driving on mountain roads, as people do now. They drive on racetracks or they go to special driving schools and they get opportunities to do something very special with a special kind of car. And those who maybe already what you've said was like the shift, automatic transmission. Many people have lost the ability to drive a manual transmission car. It's not tragic. Those who want to preserve it, please do. Just as those who want to ride horses. If you want to ride horses, please ride horses. But we have only a small fraction of the population that wants to ride horses.
Thank you, Vijay.
Yep. Yeah, when we have a question here. So the question is, do you think that we will ever develop sufficient explainability methods for understanding decisions made by neural network AI systems?
We have to. If you don't understand it, shut it down. Okay. Now, do we understand how a matrix inversion works or how a correlation coefficient works? We have to understand things at the level of our experience. I don't understand how the chip in my machine, operates. I no longer knowledge. I mean, I studied and I learned chip design, but it's long gone. I don't know how the chip works on my laptop. But at the level of performance of what I see on the screen in this Zoom session, I want to know what each of the buttons do. And so I think the lessons of HCI, of the idea of help systems, 30 years ago, there was a desire to have help systems that would explain everything. And they were, and large user manuals were also popular. But Jack Carroll's efforts on the minimal manual and the shift away from that and the standardization of design means that for a lot of systems, you can just open it up and start to use it because the commands and the buttons and the sliders are familiar to you. Now, some systems we do need to learn. So Photoshop or any editing tools may take some experience and learning to use them. But increasingly, people have used this proactive approach. I might say similarly, this is what happened 30 years ago with knowledge-based systems, expert systems, which were also predicated on retrospective explanations. But Bill Clancy and others began to discover that visual overviews and prospective, walking people through step by step and letting them make a set of choices was very effective. And that's what Amazon checkout process does, and more elaborately, TurboTax does so successfully. I think those are good models of design, and learning from those histories is important.
Yeah.
Okay, I'm ready to go on. Other questions?
So there is another question on the oversight. So it is, you highlighted 3 flavors of oversight: planning, continuous, retroactive. I'm wondering if you think any of these frameworks are particularly well or poorly suited for AI. Do we need all of the above? If we need all of the above, what seem to be successful examples of such frameworks? Off the top of my mind, nuclear regulation is only one I can think of.
Yes, I mean, I think nuclear regulation and civil aviation are examples, but notably in civil aviation, in the cockpit, there is no machine learning yet, okay? Because that's proven to be uncertain and unpredictable. The promoters of AI systems should work very hard in making the systems predictable, not because users understand how the neural net works, but because at the level of user experience, there's different levels of what users can see. And the model they see in the visual representation of the current state and future action, that it becomes predictable. I think that's essential to making success for any of these life-critical nuclear regulation, aircraft control, and so on. Again, remember, for lightweight systems, for recommender systems, for restaurants or movies, it's actually fun when it gets a strange recommendation. So you have to design based on, and the effort you spend should be proportional to the consequences of failures.
Okay, so thank you. There is another question on the YouTube channel by Tori Mortensen. Do you have any idea on critical research that will need to be done to support the HCAI framework? For example, do you foresee specific interactions or design needs that require attention?
Absolutely. I hope you got the message. I believe in visual interfaces and visual designs. I gave examples that I liked, like GPS navigation and other robot controls that give the operators a clear model of what the state is now and what will happen in the next 10 seconds, 60 seconds, or 60 minutes. I gave the ship navigation example as one to follow, but I think you have to understand when there are temporal constraints and how these things will operate. But each design situation requires a deep thought, and again, a clear separation in this fine structure design. Which things do you want to automate, and can you automate because they're reliable and predictable, and which things do you want to preserve human control? So again, the camera example shows I want human control over where I point the camera, but I will reduce my control over the lighting and the aperture and the focus. Okay, take one more.
Yeah, we have one more question on augmented reality. So do you have any thoughts on how augmented reality may enhance or pose challenges for human-centered AI system design in future work and education settings?
I like the ideas of augmented reality, and I think adding information to visual field by way of handheld devices seem like a good way. The immersive virtual reality with goggles over obscuring, they will be fun. Roller coaster rides, game playing, and other applications, maybe some surgery, and there could be successful applications for those. But I think the broader audience will be for augmented reality, which we see increasingly, where the world around us will be documented and annotated in careful ways. We'll get continuous guidance as we walk or as we drive and so on, with more information about what's nearby. I think so. Anyway, thank you. It's been a bit of a effort, the 3 hours, but I think I've held up okay. And I hope I got my message across. I hope you appreciate my passion for this. And I think the importance of presenting an alternate view of the future, a view of the future which is human-centered, where people are in charge, people's abilities are enhanced, amplified, augmented, and people feel empowered, where they're creative, where they recognize their responsibility, where their social connections are supported, and their self-efficacy is enhanced. That's really an essential point. We were talking about serving human needs and making a better world. And I think the human-centered AI community increasingly has a good view, a productive view of what the future will bring. And I'm happy to work on it, support it, and look forward to your comments and questions. Thank you very much.
Thank you. That was a very empowering message. Thank you very much.
Great. Thank you, Ossi. Thank you, Vijay, and the rest of the team for putting this together, and appreciate the, looks like we had 300 or 400 people attending, right?
Yeah. Quite a lot. Okay, and thank you, everybody.
And we just should say the video will be posted on the website, on YouTube, so it will be continuously available. Again, thank you all.
Thank you.
Yeah.
Thank you.